In this lesson, we shall focus on mathematics, right? Financial mathematics, compound interest, and simple interest, and a lot more on finance. And we cover this topic as it is relevant for this term, right? For both grades 11 and 12, this section is examined. And we're getting started with it as follows. Determining the investment value, which is the accumulated amount. Jonathan deposits 3,000 into a bank account. Right. The bank offers an interest rate of 15% per annum compounded monthly. Calculate the amount that Jonathan will withdraw after 6 years. How much will Jonathan withdraw after 6 years? So there's something we call the data. Right. First things first. Now, determining the investment value. So Jonathan deposits. Right. So there is a present value or the principal. Exactly 3,000. So Jonathan deposits 3,000 to a bank account. The bank offers an interest rate of 15%. Right. So I equals exactly 15% per annum, but it's compounded monthly. So what you're going to do is you're going to actually then say the I is precisely 15%. And 15% is exactly the same as what? Right. It is exactly the same as you divide by 100, giving 0.15. Compounded monthly, you're going to divide this by 12. Now, calculate the amount that Jonathan withdraw in 6 years. N equals exactly 6 years. Right. A couple of things, therefore, become very important. So when you use the formula A equals, because this is an investment, you're going to use the appreciation formula, 1 plus I to the nth power. The present value is 3,000. I is 0.15 divided by 12 because it's compounded monthly. And then now you have 12 times 6. So you multiply the n by the number of years by 12. And you use your calculator at the moment to get the answer. Let us practice together. Let us practice together. So we have here the task bar. Okay, in which case, therefore, we have 3,000. Open bracket 1 plus 0.15 divided by 12 raised to the power 12 by 6. Right, and the amount we're getting is exactly that one. So we are getting exactly that value there. Take a look at that. We take a look at this exactly. Right, so taking a look at this, we're able to see this particular value here. But now, is this the answer? It looks very correct. So you'd have actually, therefore, the amount 7337.76. 7337.76. 7337.76. Right. It appears, therefore, that this is the actual amount that Jonathan will withdraw in 6 years' time. Any question there, Pehelelo?
No,
Right.
sir.
Okay, no question. All right, you are the only one at the moment. You're the only one at the moment on the line. So you have a fair chance to engage. And with need, I'm going to engage you a little bit from time to time. I'll give you a chance to talk, so that I can know if you understand these things or not. And we're doing finance, which is pretty straightforward, but now we are practicing with mathematics of finance. So make sure that you're able to understand exactly what is happening here. Right, we move forward. to the next question as follows. Right, determining the investment value. Okay, it is the same question that we just did now. It is the same question that we did now. Okay, this one, determining the principal amount of the initial amount. The principal amount is also called the initial amount. A car has a current value of 250,000 Rand. If the value depreciated at 13% per annum compounded quarterly, calculate the initial value of the car 10 years ago based on a reducing balance method round off to the nearest Rand. Right, because this depreciated on a reducing balance. So we use the formula with what? Reducing balance means we use the formula with a minus. But compound interest means that you're going to use 1 minus I to the nth power. But we note our data. A car has a current value of this one. Right, and if the value depreciated at 13% per annum compounded quarterly, calculate the value of the car 10 years ago. So obviously we want to know the value of the car exactly 10 years ago. And so right now we are looking at the fact that, so we want to determine the principal, right? And so now at this point, there are several ways of doing this question, in which case what you can do is you can most certainly perform substitutions. Can perform substitutions. So that at this point, our A is 250,000. The principal is what we want. The period N is 10 years. 10 years. And I is the interest rate, which is actually exactly 13%. Right, and 13% therefore will be 0.13. Right, in which case, therefore, you plug everything into the formula. And what you're then getting is the car is the current value of this. Calculate the initial value of the car 10 years ago. Right, so you would then say, if you want this formula, you can manipulate straight away, but you substitute, it's just by substituting to the formula, 250,000, which is the present value, 1 minus the interest rate, which is 0.13, because it's compounded what? It's compounded quarterly. So every year has 4 quarters. And there you divide the I by 4, but also you multiply the N by 4, which is 4 times 10 years ago. So you multiply by 10, like that. Okay, let's look at this and think together. Look at this and think together with me. Now, at this point, you want to get the present value, which means that you must remove all this stuff. So you'll take 250,000. Present value, 1 minus 0.13, you divide by 4. 4 times 10. Okay, we divide the left. We divide the left by 1 minus 0.13 over 4, 4 by 10. Right, so in this case, you have 1 minus 0.13 over 4, 4 by 10. Okay. We're good. So what are we actually able to achieve here? So now we can see that this here is going to cancel this. And what then you're able to achieve is exactly the fact that our present value is going to be equal to 250,000 divided by that. So we have that our present value is going to be exactly 250,000 all divided by 1 minus that. 1 minus 0.13 divided by 4 to the power 4 by 10. Okay, yeah, you get the answer to this. You get the answer to this. So now we're going to use our calculator here. Let's use our calculator. Right, some of the questions you're going to try. I'm going to give you a chance to try because you're the only one here today on this platform. You have a fair chance to learn finance, and we also have statistics and probability, which is our next focus section. Okay, besides stats and probability, we also have this section on trigonometry, which is the sine, cosine rule, and so on. Okay, so those are the kinds of things that you need to learn. So you have 4 by 10. 4 by 10. So the answer we're getting is exactly 93,000 or 937,348. Right, 937,348. So that's exactly the amount. So we're getting 937,348 to the nearest rand. Yeah. 937,348. Right, so we have been actually able to obtain the actual principal. Any question on this one, Behalelo? Because I'm going to ask you some questions. There are some questions that we're going to try also. Any question? No question?
No
right.
question, sir.
Okay, that's fine. Okay, we're good. We move on. Okay, now let's look at this question. It's about determining the nominal interest rate. Nominal interest rate. So there are different types of interest rates, but this one is called the nominal. Nominal. SIPO did something. What did SIPO do? SIPO invested 15,000 Rand into in a banking account. After 5 years, he withdraws 28,000. Right, calculate the interest rate, correct, rounded to 2 decimal places per annum if it was compounded half yearly. Okay, very interesting. That SIPO invested, he just invested 15,000, but after 5 years, he withdrew exactly 28,000. So let's just draw a roadmap here and note down the data. The present value of the investment was actually 15,000 exactly. After 5 years, n equals 5 years. He withdraws a final amount of 28,000. Calculate the interest rate rounded to 2 decimal places per annum if it was compounded half yearly. So we're interested in calculating the interest rate. So we want I. Remember that this one is an investment. So you're going to use the formula with a plus. P1 plus I to the nth power. Like so. What is the final amount? 28,000. The present value, 15,000. We want the interest rate, but it was compounded half yearly. So divide this by 2. Right, and also the n you multiply by 2 because every year has 2 half years. Exactly that way. exactly that way. So what we then do is the following. We divide both left and right by the 15,000. So you'd have the 28,000, 15,000, 1 plus I over 2, 10. 15,000, 15,000, meaning, okay, you cancel 3, 3. The 3 zeros, yeah? 28 out of 15 is 1 plus I out of 2 to the 10th power. So this gives us exactly 28 out of 15. Right, 28 out of 15, and it is equal to 1 plus I over 2 to the 10th power. 1 plus I over 2 to the 10th power. And we want to get the answer to this. So what we then do is we take the 10th root. So we're going to take the 10th root. 10th root of 28 out of 15. And it is equal to the 10th root. Right, the 10th root of 1 plus I out of 2 to the 10th power. All right, this becomes the 10th root. Becomes exactly the 10th root. Right, and this gives us the 10th root. 28 out of 15. 10th root, which is 1 plus I out of 2. Which is the 10th root. 15 minus 1, which means I equals 2. The 10th root of 28 out of 15. Minus 1 like this. Right, so now we continue to use our calculator to get the results. Some of the questions I'm going to engage you. So 2 open bracket. This one here, then you have 10. And then you put here 28 out of 15. So minus 1. And then you get this, and then you get the answer out of this. 0.128. So getting 0.1288. 0.1288. Right, so if you look at that carefully, you reason 0.1288, which means I equals, you multiply by 100, you move the decimal place 2 places, 12.88%. So this is the actual rate that is required. Any question so far here? Any question so far here? No question. In the absence of a question, we move forward to the next question. So yeah, you're going to participate from time to time. I'm going to ask you some questions, not long questions. I'm going to ask you short. Because I'm trying to make sure that you learn. Okay, let's look at the next question. Let's look at the next question. Okay, at this point, we have that 2,350 Rand was invested in a fund. And this fund was paying 8% per annum compounded monthly. After 18 months, the fund had grown to a value of 3,000. and 4 rand and 53 cents. Calculate the interest rate. What formula do we use here? What formula do you think you need to use here, Perelelo? Okay, we're going to use this one because it's an investment. Now we need to note down our data. So obviously 2,650 was invested. So the 2,650 that was invested is nothing other than the principal, the present value, which is exactly 2,650 compounded out monthly. After 18 months, the fund had grown to a value of A equals 3004.53. Right, we need the interest rate, so we need I. We need exactly I. When N is 18 months. So which means that at this point, what you have here is the following. 3004.53. The principal is 650. 1 plus. You need to calculate the interest rate. Right, if it's compounded monthly, which means that we have I divided by 12. Right, and now what then you have that N is 18 months. N is exactly 18 months, like that. And you want to calculate, right, you want to calculate the interest rate, so we need I there. Okay, so let's reason these together. Let's reason these together. So obviously at this point, we divide by the 2650, and this gives us 3,004,53, which is divided by 2650, and the result is 1 plus I out of 12 raised to 18th power. Now, what is all this? What is all this? Want to get the interest rate, so we take the 18th root, meaning you're gonna actually have here the 18th root, 3004.53, you divide by 2650. And 18 here, divided by 18. Right. So which means, therefore, we have 3004.53. 2650 is equal to what? Divide like this, separate. And this would be exactly the same as 1 plus I out of 12. And you want to solve for I, so you can see that I equals, so you move this one across, and then you multiply through by the 12. So as a consequence, what then this becomes is as follows. So you're able to get 12, open square bracket, the 18th root, 3004.53. You divide by 2650. You minus 1. And now you'll be able to get the actual estimate that is required. Right, what is the estimate that is required? So let's use our calculator. Right, using our calculator, we'd have the following. So we'd have 12 times the 18th root of 3004.53 divided by 2650 minus 1. Okay, and then you get the answer. The answer is exactly 0.084. 0.084. 0.084. And then now, what would this be? So this can be actually the same as, if I is 0.084, you can write 0.084. You multiply it through by 100. Two places, meaning it is 8.4%. And therefore, the 8.4% becomes exactly the interest rate. Any question on this one so far? Any question on this particular question so far? Any question on this particular question so far? So in this particular case, we continue because there's no question and we move on. We are practicing mathematics of finance. Pay particular attention because you need to practice something also as you move along. The next question follows. Okay, this one is about Kai. Kai bought a new car 4 years ago. You now want to upgrade to the latest model. 4 years ago, he invested 60,000 for 4 years at an interest rate of 9.6% per annum compounded monthly. He will use the investment to pay cash for the new car and use the old car as trade-in, or as a trade-in. Calculate the value of his current car if he paid 160,000 for it and depreciated at 12% per annum on a reducing balance. Round off the answer to the nearest rand. Okay, let's take a look at this one and do the question about Kai. Right, so first and foremost, we need to look at what we need to do. We need to calculate the value of his current car if he paid 160,000 for it and it depreciated at 12% per annum. So in other words, the value of his current car was depreciation on a reducing balance. We use this formula here. A equals, what is the present value? He paid 160,000 minus the interest rate. What is the interest rate? It's actually 12%. So you take the 12%, you can note down the data. The present value is actually 160,000. And I equals the 12%. So if I equals 12% per annum on a reducing balance, what do you have? Which is 0.12. And now, how many years are this? Exactly 4 years we're talking about. So which means that our earn is 4 years. What else do we have here? Okay, so we must look at the symbols we have. So which means that our A is the question mark because we're saying calculate the value of his current car if he paid that. 160,000 minus 1, this 0.12. Right, so you have exactly this and the years are 4. What is the value of the car? Right, so this is what we do because the car was bought He paid 160,000 for it, and it depreciated at 12% per annum on a reducing balance. Round off the answer to the nearest rand. Meaning that you're going to calculate as follows. Take the calculator. 160,000. Then you have 1 minus 0.12. You close. To the power 4. 95951. But to the nearest rand is 95951. That's what it is. It becomes 95951. So to the nearest rand, it becomes exactly 95951. To the nearest rand, 95951. 95951. What is the next thing? We move on to the next question. Move on to the next question. Right, the next question is about assuming inflation over the 4 years is determined at 9% per annum. Calculate the current price of a similar new car. Okay. Now we are dealing with inflation. We are dealing with inflation. As we deal with inflation, we have the following. Now, what are we supposed to do here? Calculate the current price of a similar new car. So inflation, what inflation does is it weakens the strength of the currency. The currency becomes weaker. When the currency is weaker, it means therefore to buy a loaf of bread, you might be paying 1 million rand for one loaf of bread because the currency becomes weaker. We saw that in some countries, even experiencing not just inflation, but hyperinflation. Right, we saw some countries like Zimbabwe, in Southern Africa, in the SADC region, experiencing very high rates of inflation and up to the extent of hyperinflation. So now let us take a look at what happens in countries like that, but also in our South African context. Assuming inflation over the 4 years is determined at 9% per annum, calculate the current price of a new car. So now we need the current price of a new car. And to find the current price of a new car, we proceed as follows. Right, in 3.3. So now we need to reason this and reason very, very carefully. Remember that he bought the car at a present value of 160,000. And it's exactly 4 years. Right, and it is determined at exactly 9% per annum. Calculate the current price of a similar new car. Round off the answer to the nearest rand. So we need the price of a similar new car, meaning A equals. Okay, the car subject to inflation, we expect that the value is going to increase a lot of a similar new car. So a similar new car will be actually very, very expensive. So that the present value is 160,000. 1 plus I, which is 0.09. Okay, you divide this one by exactly what? You divide this one by 100 and you raise it to the power n, which is actually 4 years. So A equals, okay, 160,000. 160,000, open bracket, 1 plus 0.09 raised to the power 4, which is exactly 225,853, which is exactly 225,853. Right, so you have that this is exactly 225,853. 225,853, and therefore this is what we are exactly getting. So it means that now the current price of a similar new car is going to be too expensive. It's going to be too expensive, and it's going to be costing 225,853. 225,853. Pay attention to this and make sure you understand. We look at the next question. The dealer offers Kai a 12% discount on the price of the new car. Calculate how much cash he must still find to pay for the new car after trading in the old car and withdrawing the investment. Okay, the couple of questions that we need to obviously deal with. The question is, he's gonna trade in the old car. How much is he gonna get from the old car? Because when he trades in the old car, then he's gonna get some money. But also he's gonna withdraw the investment. If he withdraws the investment, he's gonna get some money from the withdrawal of the investment. Because if you invest money, the money is gonna grow. And now these are the things we need to take into account. So the investment was 60,000 was invested. And we did that one. Maybe let me just save time and write here that we actually dealt with the investment. Okay, we dealt with the investment. Okay, so we dealt with the investment. Right, so in other words, here's the investment. Let's see. Okay, it was the price of the new of the fact that this car now calculate the value of his current car. If he paid 160,000, it became 95,951. So this became the value of the car. And then now, okay, so the 95,951 became what? Check. 95,951 became the value of his current car. So the current car is gonna like undergo depreciation in value on the reducing balance method, and therefore this will be the 95,951 is the value of the current car. Yeah, so this one is value of the current car. Value of the current car. Now, the money that was invested, The money that was invested. Right. But also, a similar new car, it's going to cost him 225,853. 225,853. 225,853. So this one becomes the value of a similar, new car. Right, so the value of a similar new car is going to cost 225,853. Okay, next. What other information do we need here? So now we want to know how much is he going to get from the investment. But now he bought a new car 4 years ago. He now wants to upgrade to the latest model. 4 years ago, he invested 60,000 for 4 years at an interest rate of 9.6% per annum, compounded monthly. So the investment is exactly that one, 60,000 for 4 years, 9.6% interest rate. Okay. 60,000. Now, look, 9.6%, which means 0.096, but it's compounded monthly. So if it's compounded monthly, then you divide by 12. 4 years by 12. Meaning the investment of 60,000 is going to grow in value. So that money is not going to remain 60,000 after some years, but it's going to increase in value. So that's 60,000. 1 plus. Okay, now this one you can call it 9.6. 12 times 100, like 1200. Close bracket, you raise to the power 4 by 12. Getting the answer of 87954. 87954.24. 87954. 87954. Right, so getting 87954, 24, 24. That is the investment. So that in the end, you are able to get the you're able to get the amount, calculate how much cash you must still find to pay for the new car. Right, the new car is going to cost this much. So he's going to get 2 amounts of money from there. And so now he still needs, you can write like this. He still needs, right, so he still needs 225,853. 225,853. 95951. 87 from the investment, because he's going to have that investment, so that investment is sort of going to bail him out. So obviously he still needs, all right, he still needs this. Let's check how much this is going to be. 225,853. 225,853 is the value of a similar new car. minus 95951 minus 87954 87954.24. Okay, we're getting exactly 41947. Getting exactly that amount there. Let's just check. Right. Let's see. Need to check here. We need to check. We need to check. Okay, but there's a discount. Right, there's a discount you need to take into account. So let us take care of the discount. So now at this point, there's a certain discount that we need to, consider. Right, let's consider discount because it's not going to buy the car at a normal price. It's going to be discounted. So since the car is going to be discounted, you need to like filter that in because the dealer offers 12% discount on the price of the new car. So now there'll be a price after the discount. So you can write here price after discount. Right, the price after discount is going to be, so if it's 12% discount, you take the price of a similar new car, 225,853, and then you subtract 12% of this. 225,853. 12%. What answer? So you have the following. Right, so you'd have exactly the price there. Right, I'm looking for the Casio calculator. All right, I might have. Right, so you're gonna have, for example, 225,853, 225,853 minus 0.12, which is 12%, times 225,853. 198,750, 198,750.64. 198,750.64. 198,750.64. Okay, so this would be the price after discount. So the car is going to be a bit cheaper because of the discount, but he still needs to pay. Right, he still needs to pay the following. Right, he still needs to pay what? He still needs to pay. Okay, if the car is going to cost this 198,750.64 minus the value of Yeah, the value of the current car, because when it trades in the current car, it's going to get some money. It's going to get like 95951. The investment is going to give him 87,000. 954.24. So he still needs to pay the following. So he still needs to pay 198. So I want to launch my other calculator. Okay, I want to launch a bigger calculator. Just 1 sec. Right, let me launch a bigger one. Right, so now let us continue. Check this. So if we launch a bigger calculator, we're going to have the following. 198,750. 198,750. 951. 951. 87954. 7954.24. Right, let's check what you're getting as the answer. It's 14,845.40. 14,845 and 40 cents. 14,845 and 40 cents. So he still needs to pay 14,000. So obviously, I mean, we need to take into account the fact that, okay, this will be his situation, but he needs to pay something still, something small. So after getting the investment, the value of the current car, he still needs to pay 14,845. He still needs to pay exactly this amount. He still needs to pay exactly this amount. Okay? Any question there, Parallelo? Any question? Right. All right. Um, any question? Parallelo. No question. Right. In absence of a question, move forward. Right. So now in 3.5, we're saying an amount of 25,000 Rand is invested at 7.6% per annum compounded monthly. So you invest 25,000 and 25,000. This amount is invested at 7.6% per annum compounded monthly. After 2.5 years, 10,000 is withdrawn and the interest changes to 8.2% compounded quarterly. Calculate how much will be in the accounts at the end of 5 years. So this one involves what you call withdrawals. Sometimes during the investment, people withdraw some money from the bank. because when they invest, certain things happen, the car breaks down, and now they need some money, and they go to the bank and they say they've invested money and they want to get a share of the money from the bank. So obviously, these kinds of investments sometimes this affects the growth of the money, because if you withdraw the money from the bank, then you go to the bank, you take out some of the money, then that money is going to go down in the bank. So this amount of 25,000 Rand is invested at 7.6% per annum compounded monthly. We agree that after 2.5 years, 10,000 is withdrawn and the interest changes to 8.2% compounded quarterly. Calculate how much will be in the account at the end of 5 years. At the end of 5 years. So at this point, let us do the calculation together. So key to this particular question are the following things. Right, key to these are the following things. Right. So we continue. Right. Okay, we continue. So now you'll actually be in a position to do the following. Be in a position to do the following. So you need to, you're going to use the formula here because this is an investment. So you're going to use the formula A equals P 1 plus I to the nth power. But you need to remember something about the investment, because there's money that is like invested. So this money that is like invested is actually 25,000. That is invested. And it is 1 plus the 7.6% compounded monthly. So an amount of 25,000 is invested at that interest rate. Now you divide 7.6% by 100, you get 0.076, and you divide by 12. Compounded monthly. After 2.5 years, 10,000 is withdrawn. So it's invested, and then now we agree that this is going to happen in 2.5 years, meaning that you have 2.5 years, that's 2.5, and then you multiply that by 12 months, or 12 compounding times a year. 10,000 is withdrawn. Right, so and the interest rate changes to 8.2% compounded quarterly. 0.082. Compounded quarterly means that you divide by 4. Calculate how much will be in the account at the end of 5 years. Right, at the end of 5 years. So now, if it is compounded quarter now 5 years, the couple of things obviously you need to take into account here. And you can draw a timeline like this. There is time 0, time 1, time 2, time 3. An amount of 25,000 is invested. So you have 25,000 at time 0 that is just made available, is invested at 7.6% per annum compounded monthly. After 2.5 years, 10,000 is withdrawn. Right, so if these are like years, so you have 1, 2, we have 1, 2, 1, 2. After 2.5 years, 10,000 is withdrawn, and the interest changes to 8.2% compounded quarterly. right? So we note that after 2.5 years, right, we draw 10,000. So in other words, we're going to allow this, and there's going to be 2.5 years here. And at this point, we note that there's an amount of 10,000. Here, this was an investment, but here, this one is 10,000, and this 10,000 is removed. Right, the 10,000 is withdrawn, and the interest changes simultaneously to 8.2%. And it was here, all along, it was 7.6% per annum. This becomes 8.2% compounded quarterly. Calculate how much will be in the account at the end of 5 years. So in other words, you're going to continue here, and your continuation here is for another 2.5 years. So if it's 2.5 years, now we've already counted 2.5 years. Then this is like the 3rd year. And then if you count like that, T4, and then let's count T5 here. And then you count from here to here, it's 1, 2.5. So this somewhere takes us to 5 years. So which means that at this point, you need to analyze the timeline, but also take into account what is happening. Let us reason together. You need to calculate how much will be in the account at the end of 5 years. So this means that at the end of 5 years, we want to know how much is going to be there. So which means that we're going to first have the following. You see, the 25,000 is invested. And when it is invested and 10,000 is subtracted, it will actually accumulate an amount there. And this amount then is going to be pushed up for the next 2.5 years, 2.5 years to this point, which is exactly a 2.5-year journey by 4. So now we have the following. Okay, 25,000. 1 plus 0.076 you divide by 12. You close here and you raise it to the power 2.5 times 12. Like that. So you have here okay, so you subtract 10,000. Subtract 10,000 and then you close. The minute you subtract 10,000 over here and then you multiply 1 plus, and then you do division here, 0.082, you divide by 4, and then you close the bracket. You raise it to the power 2.5 times 4. Okay, yeah, we're getting 24,760. 24,760 and 75 cents. Yeah, that's the correct. So we're getting exactly that amount of money. 24,760 and 75 cents. So in other words, this is the amount of money that's going to be in the account at the end of 5 years. That is the amount of money that's going to be in the account at the end of 5 years. Any question here? Any question here? Parallelo? Right, because this thing we're using here is called the timeline, so you must be able to use the timeline if you are confronted with a situation where the interest rates are changing, because now the interest rate was 7.6% and then changed to 8.2% for the remainder of the period. And this is what grade 11 is about. So these exercises are purely grade 11 exercises that you need to understand. So this is very, very important for you. It is very, very important for you. We move on to the next question. Move on to the next question. Okay, the next question is about a guy called Tabo. It's about a gentleman whose name is Tabo. Right, Tabo paid 12,000 Rand towards a loan. Tabo paid 12,000 Rand towards a loan. And after Tabo paid 12,000 Rand towards a loan for 4 years from the date on which the loan was granted, 2 years later, he paid off the remaining 8,000. Tabo paid 12,000 Rand towards the loan. But he did that for 4 years from the date on which the loan was granted. Moreover, we're told that 2 years later, he paid off the remaining 8,000. The interest rate was 19% per annum, but compounded quarterly for the first 4 years. And then it changed, and then changed to 21% per annum compounded annually for the remaining 2 years. Determine the value of the loan that Tabo obtained from the bank. Determine the value of the loan that Tabo obtained from the bank. Now, let us do this together and analyze what is happening about Tabo, because Tabo paid 12,000 Rand towards a loan for 4 years. So for 4 years, he paid 12,000 from the date on which the loan was granted. Now, 2 years later, he paid off the remaining 8,000. The interest rate was 19% per annum compounded quarterly for the first 4 years. And then changed 21% per annum compounded annually for the remaining 2 years. Determine the value of the loan that Tabo obtained from the bank. So determine the value of the loan that Tabo obtained from the bank. So we continue. We continue to solve this particular problem. Now, there are a couple of things we need to look at here as we do this particular question. We continue as follows. Now, to determine the value of the loan that Tabo obtained from the bank, how much was the loan that he obtained from the bank? Right, there are a couple of things, obviously, that you need to take into account here. Let us reason together with me. Now you have time 0, time 1, time 2, and so on. But Thabo paid 12,000 Rand towards the loan for 4 years from the date on which the loan was granted. So you do T3, and then you're going to do T4. And he actually paid 12,000. Right, for 4 years from the date the loan was granted. 2 years later, he paid off the remaining 2 years later. So there is T5, T16. He paid off the remaining 8,000. The interest rate was 19% per annum, compounded quarterly. Right, the interest rate was 19% per annum, compounded quarterly. For the first 4 years, it means from here, the interest rate was actually 19%. 19% per annum. Right, compounded quarterly. 19% per annum, that is compounded quarterly. Right, it is compounded quarterly for the first 4 years. And then change to 21%. And then change to 21% compounded annually for the remaining 2 years. So for the remaining 2 years up to year 6, it became 21% per annum. Right, compounded annually. So yeah, annually. Right, annually. Now let's see what we got here. Annually for the remaining 2 years. Determine the value of the loan that Thabo obtained from the bank. So let us determine the value of the loan that Thabo obtained from the bank. Now, there are a couple of things that obviously you need to take into account. If you want to determine the value of the loan, the way to do it is to backdate. You take the 12,000 here and you move it back to here. And then you also take the 8,000 here and you move it back to the beginning. You move it back to the beginning. So that in the end then, if you know that A equals P1 plus I to the nth power for the loans, right? So to get the present value of the loan, what you do is you make P the subject. If you make P the subject, then you have A. So this one goes to the other side. It becomes 1 plus I to the minus N. P equals, so now you have the right, the present value. So we continue. We continue. So now I want to find the value of the loan, so we must backdate everything. So the 12,000 that was paid in 4 years, then we must take it back to the beginning so that we can know how much actually, was granted as the loan. So we're gonna take the 12,000. So in the future we have 12,000. And then now this 12,000, you're gonna take it through 19% interest rate, which is exactly 1 plus 0.19 divided by 4. Because it's quarterly and it's minus 4 times the number of the years, which is exactly 4 years. And then now we're going to take the 8,000 also. Right, so the 8,000. 8,000 was taken back. 1 plus, we divide this one by 100, getting 0.21 to, now through this 21% interest rate period, it's 2 years from year 4 to year 6. But now it is compounded annually, so it's just minus 2 years there. But now when it gets here, it's going to be exactly this amount for the 2 years, but you have to take it back further over 4 years. And now when it goes to the 4 years here, the rate is different, right? Which is 1 plus 0.19, but it's quarterly, minus 4 by 4. Minus 4 by 4. Minus 4 by 4. So that now you have the present value. So you actually do the following. So 1 plus 0.19, you divide by 4. You close like that. You raise it to the power minus 4 by 4 plus 8,000. And we have 1 plus 0.21 minus 2. You'll be like, okay, I know, 0.19 divided by 4, close bracket, all to the power, right, all to the power minus 16. So you have exactly that, which is 8,311 and 55 cents, which is exactly 8,311 and 55 cents. Any question on this one so far? Any question on this one so far? Kakalelo, do you have any question? Do you have any question? No question. Right, in the absence of a question, I'm giving you homework. This is your homework. For 7 marks, grade 11, this is your homework. So this one would be your home activity. So this one becomes your home activity. This home activity is about Asanda. Asanda inherited 36,000 Rand. He invested the money in a savings account, paying 9% interest rate per annum, compounded monthly for the first 2 years. He then withdrew 10,000 for his studies. At the same time, the interest rate changed to 8.8% compounded quarterly. 3 years later, he deposited a further 2,500 and left his investment to grow for a further 4 years. At the same interest rate, calculate how much was left in the account at the end of 9 years. At the end of 9 years. Right, so this one is your home activity, Perelelo. Any question? Any question, Perelelo?
No, sir.
No question. So I'm gonna post, yeah, that's fine. I'm gonna post this video in the next couple of minutes, okay? So you can watch it. And then this homework you can do during your own leisure. I'll be interested in seeing how you're gonna do this question on Asanda. Okay, because it's gonna be part of the video. So even if you do not copy it down right now, but it's gonna be part of the video that I'm gonna send in the next few minutes. Okay. And then you're gonna watch this video and you know, try the question and during the week when you get a chance, I mean, it can be during the weekend, the coming weekend, because sometimes you told me you know that you don't have access to the phone, you don't use your phone much during the week, which I understand. Maybe during the weekend, then when you tried this question, we can take a look and see how you did there. But yeah, I have thousands of the questions here on my system, but I think that this is enough for today. And this is your homework for today. And yeah, I'm gonna keep posting on the group to check on you guys during the week, you know, to see how you guys are gonna be doing, because you guys are gonna be writing tests in August, September. Gonna be writing some September tests normally. And I'll be interested in seeing how you guys are prepared for those tests in view of term 3, term 4 work and term 1, term 2. But term 3, term 4 is what we must, you know, put a bit more effort to sort of cover and recap on. Those sessions are coming where we're going to have more interaction, more talking, more practice, and you'll be part of the learning than just being a spectator and just being a listener, you know. Yeah, but yeah, it was awesome having you now. Until next time, take care. We're gonna post on the group. But yeah, my plan is we meet every weekend, Saturday and Sunday, but I'm planning that during the week. So I'm gonna check on you guys during the week to see if you are available at 8 p.m. or not. At 8 p.m. during the week. I'm gonna check on you guys. If you are not available, it's okay. If you are available, it's okay. Then we can do more. Okay. Right. Thanks a lot, Pegalelo. And it was awesome having this lesson. Your home activity is there. And take care. Until next time, goodbye. Goodbye.